In problem number 21, we have the same denominators here, so that makes it somewhat easy. But we have a minus sign here, so we just need to be careful that we subtract this entire quantity. And we can do that. Let's write it as, all right, or here's our p plus q minus, now get the entire quantity by writing it in parentheses. So we've got our p plus q minus all of that p plus q, and it's all over 18. Let's eliminate these parentheses here. Take that minus sign through, so we're going to have p plus q minus p plus q, right? Minus p, and minus a negative q is minus, a minus is a plus. All right, and the whole thing is over 18. And then what we've got is this p minus p, well that's 0, so that's gone. And we've got a q plus q, so we get 2q over 18, and then the 2 and the 18, well, they're both even. They have a 2 in common. So 2 will go into 2 once, 2 will go into 18 9 times, and then what we'll have here is q over 9. Now again, here in number 21, we've got common denominator z plus 3. So why don't we start here? Let's just draw our big parentheses and write that common denominator there. And in the numerator, since we have the same denominator, we can just combine. So we'll get a z squared plus the 3z. So let's write that one. We'll get z squared plus 3z. And now, as we do with all rational expressions, we ask, can we reduce this? And we reduce by factoring and canceling. So we can take a z out of here. So let's take that z out. This will leave us with a z plus 3. What do you know? And a z plus 3 in the denominator. And these z plus 3's will cancel, leaving us with just a z. So what this says, let's just look at the big picture here. This says that this set of computing instructions can be replaced with this. So if you put a number, you can put a number in and evaluate it using this expression. So pick any number. Put it in here for all the z's. Like if you pick 8, you do all this work, you compute, what do you get back? You could use this one. Put in 8, you get back 8. Put in 10, you get back 10. These are much more efficient, much more compact. Now, once again, in number 25, we've got two fractions with the same denominator. So we're just going to combine those numerators. So let's draw a fraction bar here and use the same denominator, the LCD. And in the numerator, we're just going to take this left top minus the right top. But be careful, we've got a lot of negatives there. So it's going to be, I'll write it all. It looks like x minus that negative 8. So this is going to give us x plus 8 over, now let's go ahead and factor this denominator, right? It's like calling out to us. Difference of two squares, factor us as conjugates. X and x, 8 and 8, one's plus, one's minus. And then what we can see is that these x plus 8's will cancel, and we are left with 1 over x plus 8. Now just note here, when we cancel these x plus 8's, when you draw that cancellation line, there's really a 1 there. So when I draw that line, I really get a 1 and a 1 here. So I get 1 over, get that 1 over the x plus 8 times 1, which is just x plus 8. Now this one's a little bit different than what we've been looking at. This one, in this one we have different denominators, right? We've got x minus 3, x plus 3. So let's start out by factoring the denominators to see what our LCD is going to be. So on the left side here, this is already factored, so let's just rewrite that as x over x minus 3 minus, okay, a plus, we'll have a negative 18 over, this is a difference of two squares, how about x plus 3, x minus 3. Now we can get our LCD. We've got this factor here, x minus 3, and this one here, x plus 3. So let's write our LCD. The LCD is x minus 3, x plus 3. You know what, I'm going to circle it, so I've got it here. Now, here's how I like to do things. Let's do it up here so we get some room. I'm going to write a big fraction bar, and I'm just going to write LCD in the denominator because I know eventually these two fractions are going to have the same denominator, and I combine them together just like we did over here, right? I got it. Same denominator, big line, same denominator. Same denominator, big line, same denominator. So we know that's what we're going to do. So big line, same denominator, and instead of writing it all out, I'll just write LCD. Now on the left side, we've got this x. So I'm going to write that x, but I'm going to have to adjust that because I've adjusted the denominator, right? We had x over x minus 3, but now the denominator is not just x minus 3, it's x minus 3, x plus 3. So it looks like the denominator has been multiplied by x plus 3, so we need to adjust this numerator by multiplying it by x plus 3. And then we'll have a plus. Then we've got this negative 18 here. All right, I've got that negative 18, a little awkward. Now compare this original denominator to the new one. It's right below each other. No change, right? There's no adjustment in the original denominator, so no adjustment to this numerator. We're just going to have negative 18. So let me just finish this one out here now. What we're going to have is we've got that minus 18, so we're going to have multiply through here. We'll get x squared plus 3x minus the 18. Now we're going to factor the x squared plus 3x minus 18 into x plus 6x minus 3. Now we can't do anything more in the numerator. So let's actually write the LCD now, and we can see when we do that the x minus 3's cancel, and our result then is x plus 6 over x plus 3. So what we're saying here then is that this original expression here can be replaced with this expression, and let's just go ahead and do it this time, as long as x is not equal to negative 3, right, that's from here, or negative 3 from here, and positive 3 from here.